This is lesson 2.2, linear relations and functions. So a linear equation has no operations other than addition, subtraction, multiplication of a variable by a constant. So that means that the variables may not be multiplied together or appear in a denominator. Also, a linear equation cannot have any variable with exponents other than 1. And like its name says, the graph of a linear equation is always a line. Now, a linear function is a function with ordered pairs that satisfy a linear equation, and any linear function can be written in the form of f of x is equal to mx plus b, or y is equal to mx plus b, where m and b are real numbers. So coming down to example 1, is this a linear function? And explain. We want to see if it can be written in the form f of x is equal to mx plus b. And since the answer is yes, we can say yes. It is a linear function because, or since, it can be written in that form as f of x is equal to negative 1 over 5x. So notice I'm separating out that coefficient from the variable, plus 0.2 as that y-intercept. All right, so that's an example of when, yes, it can be written as a linear function. Now, example 2, can that be written as a linear function? We would say no, that cannot be written as a linear function, and that's because the variables x and y are being multiplied together. It's because x and y are multiplied, which means that this can no longer be a linear function. All right, so go ahead and try these exercises, numbers 1 through 6, on your own, and you can check in with your neighbor and see if they get the same thing if you're not sure. And then once you're done, go ahead and unpause this video, and I'll have the answers ready for you. All right, so here are the answers for exercises 1 through 6. Number 1, the answer is yes, it can be written as f of x is equal to 1/6 x plus 7 over 6. Number 2 is no, since the variable y is in the denominator. Number 3 is yes, it can be written as f of x is equal to 1 over 12x plus 2. Sorry about my horrible handwriting. Number 4, yes, it can be written as f of x is equal to 2 over 3x minus 5 over 3. Number 5, no, since the variable x has an exponent of 3. And number 6, the answer is no, the variables x and y are multiplied. All right, so that's what it means to be a linear function. Let's go ahead and continue on to standard form. So standard form of a linear equation has to be a linear equation, but if it's written in this form right here, it is considered standard form. So ax plus by is equal to c. Now the thing is, a, b, and c all have to be integers, and that's super important. So it can't be a decimal, it can't be a fraction. Also, they need to be numbers where their greatest common factor is equal to 1. So greatest common factor is equal to 1 between those three. So basically they have, it can't be like 2 is A, B is 4, C is 6, because then their greatest common factor would be 2. All right. So let's go ahead and practice writing some equations in standard form. Whoops. Ooh, sorry. All right, and then we have to identify A, B, and C. Okay, so the first thing I would do is I would move everything except the constant to one side. So anything with a variable, I'll go ahead and get to one side. And a has to be positive, so I'm going to go ahead and multiply everything by -1. And that's it for standard form. All right, and then I just identify that a is 8, b is -1, and c is 5. And you notice that their greatest common factor is 1, so that is my final answer. Okay. For b, I'm going to add the 7y. And now I can go ahead and divide everything by 7 to simplify that down even more. And now this is the equation in standard form, where a is 2, b is 1, and c is 3. All right, and that is my final answer. Okay, let's go to the next page. Now, example 2, we have find the x-intercept and y-intercept of this graph, and then graph the equation. Now, to find the x-intercept, this is when the y-coordinate is equal to 0. So, to find the x-intercept, that means y is equal to 0. So when I substitute y is equal to 0, that leaves me with 4x is equal to 20, which means my x-intercept is equal to 5. And I do the same thing for the y-intercept. All right, now when the y-intercept is what I'm looking for, I set x equal to 0, which means I have -5y is equal to 20. So my y-intercept is going to be -4. All right, so x-intercept is 5, y-intercept is 4. Okay, and then I can just use those two to graph the equation. So my x-intercept is +5, so that is right there. And my y-intercept is -4. Oops, forgot to put a negative there. And just connect those two dots, and that is your line. Hopefully yours looks a little bit better than mine. Okay. Now go ahead and try these exercises. Finish off the rest of this page, numbers 1 through 9, and pause this video. And once you are ready to check your answers, go ahead and unpause to check your answers. All right, here are the answers for the exercises on the second side. We have number 1 in standard form, 2x minus 4y is equal to -1, which means a is 2, b is -4, c is -1. Number 2, we have 2x minus 5y is equal to -3, a is 2, b is -5, c is -3. Number 3, we have 8x minus 6y is equal to 3, and a is 8, b is -6, and c is 3. Going on to number 4, we have 8x minus 9y is equal to -60, a is 8, b is -9, c is -60. Number 5, we have 2x plus 15y is equal to 50, a is 2, b is 15, and c is 50. And number 6, we have x minus 3y is equal to -2, a is 1, b is -3, and c is -2. All right, going to number 7, we have the x-intercept of 7, y-intercept of 2, and that's the graph. The answer for number 8, the x-intercept is -10, y-intercept is 2. Now, because it didn't fit in the graph provided, I changed the intervals from going by 1 to going by 2. And so make sure you mark that clearly on both the x and y axis so I can see that both of those are rescaled. All right, and lastly, number 9, we have x-intercept of -3 and a y-intercept of 1.5. All right, so we have our x-intercept, you can see there at -3, and then y-intercept, you approximate that 1.5 right in the middle, and you can draw your line. All right, and that is it for this lesson.